Hi, welcome back to Solve It with Arash. In today's video, we are going to explore Vieta's formulas for cubic polynomials. These formulas will help us to find relationships between the roots of a cubic equation and its coefficients. And we will walk through an example to learn how it works. But before we start, if you have not seen my video on Vieta's formulas for quadratic functions, I highly recommend checking that out first to learn the basics. I will leave the link to the video in the description below. If you enjoy math content and you like to see more, please like and subscribe. If you have any questions, comments, or feedback, please leave it in the comment section. Now, with no further ado, let's jump in and solve math problems. If p, q, and r are the roots of function f at x, then find the sum and product of the roots in terms of the polynomial coefficients. X cubed minus 2x squared minus 5x plus 6. Using the factor theorem, we can write the function as k times x minus p times x minus q times x minus r. Since the leading coefficient is 1, then k is 1. So x minus p times x minus q times x minus r is f at x in factored form. Now if I expand this factored form, I will end up with x cubed minus p plus q plus r times x squared plus pq plus pr plus q times r times x minus p times q times r. Now since this expression is equivalent to x cubed minus 2x squared minus 5x plus 6, then the corresponding coefficients must be matching. Therefore, p plus q plus r is equal to 2. They are the quadratic coefficients. So p plus q plus r equals 2. Next, pq plus pr plus qr equals -5. So let's write that down here. Plus qr equals -5. And lastly, since negative pqr equals 6, then p times q times r equals -6. These three expressions are called the symmetric sums. Now that we've solved an example, let's see how it works for any cubic polynomial function. F at x equals a3x cubed plus a2x squared plus a1x plus a0. Once again, we use the factor theorem and rewrite this function in the factored form. a3 times x minus p times x minus q times x minus r. I use a3 as the coefficient of the factored form to make sure that the leading coefficients on both hand sides are matching. Now I expand the right hand side and we will have a3x to power 3 minus a3 times p plus a3 times q plus a3 times r times x squared. Next, I'm going to expand the right hand side. a3 times x cubed minus a3 times p plus a3 times q plus a3 times r, close the brackets, and times x squared plus a3 times pq plus a3 times qr plus a3 times rp multiplied by x minus a3 times pqr. Now, since the two equations, the original one and expanded form, are identical, their corresponding coefficients must be equal. On the left side, the first one is a3, on the right side is also a3. For the quadratic coefficient, we have a2 on the left, on the right we have negative a3 times p plus q plus r. For the linear coefficient, on the left side we have a1, and on the right hand side, if I factored a3, it's going to be a3 times pq plus q times r plus r times p. The constant term is a0 on the left, and on the right we have negative a3 times pqr. Now the goal is to find the symmetric sums, which are p plus q plus r, pq plus qr plus rp, and pqr. From this equation, p plus q plus r equals negative a2 over a3. The next symmetric sum can be found from this equation. where PQ plus QR plus RP equals A1 over A3. The product of roots, which is another symmetric sum, can be found using the last equation, where PQR equals negative A0 over A3. I think I missed one here. The previous row, I had A1 over A3, and then the last one, it's negative A0 over 3. Now this is called the Vieta's formulas for cubic polynomials, which includes three symmetric sums, and it connects the roots of the cubic equation to its coefficients. Like p plus q plus r, the sum of the roots is negative a2 over a3, which means it's negative the quadratic coefficient over the cubic coefficient. And the product of the roots, pqr, is negative the constant term over the leading coefficient. That's it for today's lesson on Vieta's formulas for polynomial equations. I hope this breakdown makes it clear on how to use Vieta's formulas to find the sum and product of the roots from a cubic equation's coefficients. Remember, if you want to learn how it works for quadratic equations, you can always check out my previous video, and the link is in the description. If you enjoyed this video, please like, subscribe, and share with your friends who love math. Thank you for watching. See you next time on Solve It with Arash.